Mesa College Radiologic Technology program. So we're going to start off with darkrooms and viewing conditions. Just a little note, I was a darkroom tech for 3 years before I became a radiologic technology tech. So yeah, this was my life. So let's get into it. So we have to process the film. It has to go through a processor, either a regular processor that goes from a darkroom out to the lighted area, or a daylight processor. With the darkroom, basically we have a film bin, and I'll have a picture here to show you that, since maybe some of you have never seen one. But there's a film bin, and know a lot about film bins because students used to expose films all the time, and I get a call from the manager talking about how this student exposed $100 worth of film. Anyway, let's get on with it. We have a feeding tray for the film. That's on the processor itself. We put the film down on the feeding tray, and it eats it up and exposes it and develops it and shoots it out the other side. There's a pass box that the cassettes are put into, and then totally dark with Safelights. So it's really dark in there. Usually, typically a red Safelight that only emits the red frequency, so it will not expose those films. A daylight processor basically empties and loads the cassettes in a lit room, and the cassette goes right to basically into the machine. The film is taken out of the cassette and right into the developer and fixer. So that was a very nice addition to our departments when that happened with the daylight processors. So in the darkroom itself, you're going to have Safelights. You're going to have an entrance, a couple different types of entrance. We have a pass box, which you would put your exposed film in one side, and it says exposed, and the other side would have clean films in it. So let's say someone's doing a fluoroscopy exam, and they have like 10 films to, or let's say they're continually feeding the pass box with films. We would need to know which ones were exposed and which ones were not, and also to get the fresh ones out to the techs so they would have more films to take more overheads. And then we have the ventilation, and all darkrooms need to be well ventilated because of all the chemicals. So real quick, the darkroom entrances, typically you're going to find a revolving door at these entrances, but you could have a single door, which is taking a real big chance if the bin is open and exposing those films to the light. Double interlocking doors, okay, that takes up a little more space, as does light-proof maze. I don't believe that most hospitals would forfeit all the square footage you would need for a light-proof maze, but these are the different types of darkroom entrances. And here's this revolving door that I'm used to myself. Typically what would happen is a person would go in there, and there is overhead lights, and then there is the red light, and so as soon as the overhead lights, the white light, gets turned off, this darkroom light would turn on, usually above the door itself. So the function is to protect the film. What is the darkroom function? It's to protect the film from the visible light, protect it from ionized radiation. It is lead lined also. Excessive heat and humidity. You have to keep conditions pretty constant there. Static electricity can cause all sorts of problems with film also. If it's very, very windy outside, it causes a lot of static electricity, and if you were to touch a film and let's say give a shock to the film, you would actually see almost a lightning bolt pattern through that film once it is processed. It's kind of really interesting there. Make sure the pressures are right in the room itself and chemical fumes are ventilated, and basically keeping the films protected from that also. So latent suffocation is basically once this film, and we know what a latent image is, right? It's where the image is on the film, it just has not been processed. We can't see it yet, but the image is there. That is a latent image. So latent suffocation is when the film has been exposed, has been exposed to radiation, but now that's activated those crystals, those silver crystals in there, and the film is 2 to 8 times more sensitive to the exposures as an unexposed film. So it's almost like once it's been exposed once and hasn't been processed, it's very, very highly sensitive to more radiation. So the darkroom must prevent fog. So this is non-informational optical density, right? Just like fog or scatter radiation that we find on that we get on our film, it doesn't do us any good. It gives us no diagnostic information. So again, fog is defined as a non-informational density that occurs because silver grains are formed and do not represent any of the anatomical structures within the patient. It's useless, so we don't want it. So we must prevent the static electricity. Like I mentioned, you can kind of get that lightning bolt appearance that goes through the film. So countertops, rubber floor mats, and other work surfaces must be grounded, which they are. Proper film handling. You don't want to rub it against your wool sweater or anything like that. Maintain a relative humidity range of 30 to 60%. Most of the times that is out of our control, but we need to know that. And the psychrometer would measure the humidity. Regular film screen cleaning with an anti-static non-abrasive cleaner, and that would really help to reduce the static electricity for the films there. So it must be ventilated well. It removes the excess heat in there, and like I said, being a darkroom tech myself, it does get very, very warm in there, especially when we started having angio cases and had 30 films to run at each time. So it removes the excess heat and humidity. It reduces exposure of potentially hazardous chemicals to personnel. I'm here to prove that it didn't affect me at all. Requires about 8 to 10 room changes of air per hour. So I have to have a good ventilation there. And the temperature should be 65 to 75 degrees. I will tell you, I got hotter than that many, many times. So the chemical fumes must be vented to the outside of the building. So that's something for the contractors to figure out and to get all those lovely fumes out to the outside so people on the outside can smell them. Okay, so probably needless to say, shouldn't be eating, shouldn't be smoking inside the darkroom. I can't really speak for anything below, before the 1980s, but it seemed like everybody was smoking then. No food, no smoke. I don't think you can smoke on any hospitals anymore. Darkroom characteristics: water and drainage. Conventional film processors require a supply of cold water. So the new units really, have heaters, and the old ones you just actually have to put the hot water in there and gauge that. Must also have adequate drainage of 10 gallons per minute. So we went through quite a bit of water when we used these. And again, they're out there, they're being used, typically in doctor offices, sometimes in surgeries and things like that. That's usually where chiropractors' offices, things like that. Storage space. So for film, we have to have a film bin, and we can't put anything on top of the film. You open the box, you actually put the box of film in the bin and then open the box while it's in the bin. That way there's no chance of it coming loose in your hands and all over the floor, creating dust, dirt, static electricity, all sorts of fun stuff. And we need to keep those films between 55 and 75 degrees Fahrenheit. When looking at the chemicals that process the film, we need to keep that at 40 to 80 degrees Fahrenheit. The developer is sensitive to light, so it's very important to have that in darkened out bottles, and they would pour that into the processor and not try to subjugate it to too much light. Contains potassium, so we need to keep it away from the film because that would show up, that would actually develop our film somewhat. And it has a 12-month expiration on those darkroom chemicals. So here's a film bin. This is what they look like. This is more along the lines of what I'm used to. And they would basically have you 14 by 17. We had something called a 7 by 17, and we used to have 9 by 9s. Those are all gone now. You used to have 11 by 14s. I think most of you are used to your 8 by 10s, your 10 by 12s, and your 14 by 17s anymore. And then, of course, we have that Panorex film also. Okay, so we do have some overhead lighting, meaning it creates the white light so we can get in there. Sometimes to do some cleaning or maintenance, could be an emergency or something like that. We need some real lighting that's going on in there besides the red overhead light. What would happen is that when you would turn on the white light, it would actually lock the film bin. Now, a few places had this, but not everybody. So we just usually would have to be up on our toes and make sure that we didn't turn on the light when the film bin was open. And a lot of times what would happen is that we'd have an alarm on the film bin to let you know if it was open or not. That would have been convenient. So even the best safe lights emit some light, so it's important not to leave the films open in the safe light. Latensification, again, not more than 40 seconds in the safe light. Remember we talked about latensification? I have an idea, it'll probably be on a quiz or a test. And it's talking about how that's kind of made those silver elements in the film more sensitive. So basically the safe lights are mounted about 3 to 4 feet away from the feeding trays. Enough to where you can see it, but not enough to expose too much. So there's a couple different ways that the film is sensitive. So blue-violet sensitive film is the most common in screen cassettes. It's sensitive to blue, indigo, and violet. So what kind of safe light would you use for that? You would use your amber colored safe light, which would be your red, orange, or even some yellow. Typically red. So speaking of red, good old Kodak's GBX filter. So GBX stands for green, blue, X-ray. And essentially X-ray film, what it's sensitive to. So it is dark red. It's low intensity. Usually it would max out around 15 watts. We need a little bit of room or a little bit of light to see what we're doing. 4 feet away from the work area, and direct illumination possible with most films, meaning that you could shine this red light down into the bin, the film bin. Granted that you weren't going to be leaving it open for a very long time. So there's also a Kodak Radt series 6B. It's orange bound filter, amber filter, safer film sensitive to it. Also is that amber filter light that can be used. So here's the fixture type. Contains the light bulb covered by a filter 6B for the blue-violet sensitive. And now we also have a light emitting diode, or LED, which again is just like the ones that we buy for our house. Is a high initial cost, but they will last a long time. Really what matters is the filter that they put over that. Usually it's the red filter, not so much the light source itself. So safe lights are left on for more than 24 hours a day, 7 days a week, and need to be filtered, have the filter changed annually, because actually that red filter starts to fade once it's exposed to light continuously like that. If and when you go into a dark room, you'd notice that the benches or the countertops and the flooring typically are of a lighter color, just because we are walking around in, let's say, 15 watts or less, and we kind of need to see what is going on. So typically the benches and flooring are a little bit lighter, so that if something falls and things like that, we can find those. There are some large dark rooms that use a sodium vapor lamp, and these are used really for a large area, but still need to maintain that light level so it's not going to expose our film. An LED safe light uses a light emitting diode as light source, possesses low electrical power consumption, which is great and can last up to 15 years, just like the ones in our house. So there's a leakage test that we can do for a darkroom. We turn out all the lights and wait for 5 minutes. We observe all the darkroom areas for light entry and repair if necessary, and we turn on the lights and check the ambient temperature, feeding tray, and the work counter cleanliness conditions. Typically what we would do is we'd leave a film out for 5 minutes and just see. And sometimes it might have been from the safe light, but usually if there's any real light, white light coming through, you'd see that exposing that film real quick. Back in the old days, we used to have something called a duplicating unit, and we basically would take a film that was already exposed and place it another film on top of it, and we would use that to basically duplicate the film. So we'd have two. We wanted to keep our optical densities below 2.5, keep it very nice and sharp image there. The quality control testing involves copying an existing sensitometer or penetrometer image, so basically like a grayscale image, and then you would make a copy of that, and then you would compare that copy with the original to see if the densities are basically similar, or should be at least within 0.02 of each other. So here it is. Here's the film duplicator. You would basically put your already exposed film that has an image on it, and then you would put a fresh film on top of it, lay that flap down, and set it for the certain amount of time, and it would basically duplicate the film, and we would process that other film, and we'd have duplication of each other. Amazing technology.